Hello friends, in the last video we have seen three important definitions. First definition is statement, second definition is truth value, and third definition is open sentence. Using these three definitions, even we have completed question number first from exercise 1.1. So now today we are starting next part of this chapter. So let us begin with the first definition, logical connectives. Now 5 words which are used to connect two statement are called as what? Logical connective. Let us try to understand which are these 5 words. So these 5 words are and, or, if and only if, and if then. And, or, if then, if and only if, and not. These are nothing but 5 logical connective. Which 5 word? And, or, if then, if and only if, and not. These are called as 5 logical connectives which are used to connect two statement. Not is not used to connect two statement, but till in mathematical logic it is also called as what? Connective. So now let us try to understand the next important definition, simple statement. Simple statement means in a statement no logical connective appears, or in other word we can say that a statement which cannot be split up in 2 or more statement. So let us consider here one example, that 3 and 5 are odd number. If we will decided to split up it into 2 part, what will the first part? 3 is odd number and second part is 5 is odd number, means we are splitting it into 2 part. So at that time the statement is not called what? Simple statement. When we can say that statement is simple? If it is not split up further into 2 part. Just take an example, 5 is odd number, we are not able to split up it into 2 statement. So such type of statement are called as what? Simple statement, or simple definition, if no logical connective appears in a statement, at that time it is called as simple statement. Now compound statement. Compound statement means such statement which can be further split up into 2 or more simple statement. So these are some example of simple statement. If one statement is given to us and if it is further split up into 2 or more statement, then such statement is called as what? Compound statement. Just take an example, Taj Mahal is in Agra or in Delhi. So if you are deciding to split up it into 2 part, so what will the first part? Taj Mahal is in Agra, and second part is what? Taj Mahal is in Delhi. So means these 2 statement are connected here by what? Or. So and which new statement we have got here? Taj Mahal is in Agra or in Delhi. Getting it? Means here this statement, in this statement we are able to split up it into 2 part, or if any statement is split up it into 2 or more part, at that time it is called as what? Compound statement. Or in other word we can say that it is combination of 2 or more simple statement, then such statement is called as compound statement. But simple definition, if no logical connective appears, if one or more logical connective appears in the statement, at that time it is called as what? Simple statement. It is called as compound statement if one or more logical connective appears in it. Now the next very important part of this chapter is truth table and symbolical representation of logical connective. Just now we have seen that how many logical connectives are there? 5 logical connective. We are now discussing symbolical representation of these 5 logical connective and truth table of these 5 logical connectives. So let us begin with one of the logical connective, not. Not is also called as negation. What is alternate word for not? Not is called as what? Negation. And statement, already we have seen in the last video that statement are denoted by small letter like P, Q, R, S, etc. If I am denoting the statement by P, then it's negation. Negation means what? Negation, this word is used for which logical connective? Not. If we are using not in this statement, means if we are finding negation of this statement, then symbolically it will be denoted by this notation, negation P. This notation which we have used in similarity to show that 2 triangles are similar. So this notation in logic is used for which logical connective? Not. Is it clear? So hope the idea about symbolical representation, because we are discussing symbolical representation and what? Truth table of logical connective. Total 5 logical connectives are there. We are discussing about which logical connective? Not. If P is one statement, then its negation is denoted symbolically by this notation. Now we are discussing about truth table. First let us construct the truth table of this first logical connective, and considering it as an example we will discuss the definition of truth table also. So here if we are considering one statement P and we are finding its negation of P is denoted by this notation. Means this notation says that we are using negation, means not in this statement. Is it clear? So if P is one statement, then there are two possibilities, either it is true or it is what, false. Now if the statement is true, then let us try to find out its negation. Just consider one example of true statement. So 5 is odd number. Is it true? Yes, 5 is a odd number, it is true. Now if we are using negation in it, means if we are using not in it, what result we will get? 5 is not odd number. Now what you can say about truth value? 5 is odd number is true and 5 is not odd number means what? It is false. Means simply you have to remember that if statement is true, then its negation is false, and if statement is false, then its negation is what? True. So in this way we are easily able to remember the truth table here, isn't it? If the statement is true, then its negation is false. If statement is false, then its negation is what? True. Now let us try to understand the definition of truth table. This table shows what? Truth value. T and F are nothing but what? Truth value. The table which shows truth value of all possibilities of the statement under consideration. As it stands, how many statements are under consideration? Only one statement is under consideration, which is that statement P. If P is one statement, then how many different possibilities of truth values are there? Only two possibilities are there, either it is true or it is what? False. Only two possibilities are there. So and if we are considering all possibilities, this table shows truth value of all possibility of the statement under consideration, then such table is called as what? Truth table. So hope you have got it. If one statement is under consideration, then how many different possible truth values are there? Maybe possible that it is true, or maybe possible that it is what? False. There is no another possibility. So this table shows truth value of all possibilities of the statement under consideration. Such table is called as what? Truth table. Our maximum syllabus of this chapter is depend on what? Truth table. So try to understand the symbolical representation and truth table of these logical connectives. Now let us discuss about second logical connective. Our second logical connective is and if we are instead of and if we are using but at that time also, meaning of statement does not changes. That's why instead of and you are able to use what? But also. And this logical connective is called as conjunction. If P and Q are two statement, if P and Q are what? Two statement, and if we are connected these two statement by and means what? Conjunction, then symbolically it will be denoted by this notation, and it is read as P and Q, or it is conjunction of P and Q. So hope the symbolical representation is clear to you. This notation is used for which logical connective? And. Now let us discuss about truth table, because we are discussing truth table and what? Symbolical representation. Hope the idea about symbolical representation of conjunction means and is very clear to you. Now let us try to construct its truth table. Already we have discussed the definition of truth table. What is this definition? The table which shows truth values of all possibilities of the statement under consideration. As it stands, how many statements are under consideration? Two statements are under consideration. Which two statements? P and Q. So let us try to find out possibilities of all truth value. One possibility is that there may be possible that both the statements are true, or second possibility is that both the statements are what? False. Both the statements are false. Otherwise, may be possible that first statement is true, means P is true and Q is false, or P is false and Q is true. So total how many different possibilities we are getting here? 4 possibilities if two statements are under consideration. So these 4 possibilities in the standard form can be written in this way. In the first column write down TT, FF, and in the second column TF, TF, isn't it? So this is the way of presenting the truth values if two statements are under consideration in the standard form. Now we are finding the truth value of new statement which we are getting by connecting these two statements. So let us suppose that P is one statement that 2 is even number. Just I am considering one true statement, and Q is also, in the first case, Q is also what? True statement. Let us consider here 4 is even number. Now both the statement are true. By connecting these two statement by what? And the new statement which you are getting, that statement is true or false, that we have to identify. Let us connect these two statement by and. 2 and 4 are even number. Yes, the new statement, after connecting them by what? And we are getting what? True. So let us suppose that this in the first case here what result we are getting? True. Now let us convert one statement into false statement. Let here this will be say odd number. So if I am saying that it is odd number, at that time we can observe that second part means Q statement is what? False. 4 is odd number, it is false statement, because we know that 4 is even number. So now if we are connecting these two statements by which logical connective, and let us see what result we are getting. 4 is even number, but 2 is even number, but 4 is odd number. So what is your conclusion? So if you are connecting them by but means what? And. So what result we are getting? The new statement, 2 is even number but 4 is odd number. So which is nothing but what? False. We can observe that here 4 is odd number is one part of the statement if we are connecting these two statements by what? And. So easily we can observe that if at least one statement is false, at that time truth value of P and Q will be what? False. Otherwise here if I am taking 2, now 2 is even number is what? True statement, and 2 is odd number is what? False. Now if I am connecting these two statements by what? And. One is true and second is what? False. Let us see what result we will get. 2 is even and what? Odd. Means 2 is even as well as odd. Is it possible? No, because we know that 2 at a time it can, 2 is even also and odd also, it is not possible. So if we are connecting one true statement and one false statement by which logical connective, and at that time result will be what? False. So in this way, not necessary to give the example for remaining cases, just simply you have to remember that if at least one statement is false, truth value of and will be what? False. अगर एक भी स्टेटमेंट एंड में एक भी स्टेटमेंट फॉल्स अगर है तो एंड की ट्रूथ वैल्यू क्या होंगी? फॉल्स होंगी. एटलीस्ट वन स्टेटमेंट इज फॉल्स, एट दैट टाइम ट्रूथ वैल्यू ऑफ एंड विल बी व्हाट? फॉल्स. नाउ थर्ड लॉजिकल कनेक्टिव इज व्हाट? और, which is called as disjunction. Now here also we have considered two statement, P and Q are two statement. If we are connecting these two statement by or, means which or means what? Disjunction. Means if we are finding disjunction of P and Q, at that time symbolically it will be denoted by this notation. So P or this V symbol like V is used for which logical connective? Or. So symbolical representation is clear to you. Now we will discuss about truth table of this logical connective. So here also, since two statements are under consideration, so which are the four different possibilities? In the last case we have seen that true true, true false, false true and false false. These are what? Four different possibilities if two statements are under consideration. Now in this case, if both the statements are true, at that time the new statement which you are getting by connecting these two statements by or are what? So see here, 2 is even number and 4 is even number. So now we are connecting these two statements by which logical connective? Or. Both are what? True. Let us check whether the truth value of new statement is true or false. 2 is even number or 4 is even number. So what is your conclusion? So as all of you are the student of science, so all of you are very well aware with the English. So what result we are getting? 2 is even or 4 is even. So the new statement which you are getting after connecting these two statements by or will be what? True. Now let us make one statement what? False. 2 is even number. I am replacing even by what? Odd. Now I am connecting these two statements. One is true and another one is false. First is true and second is what? False, because 2 is odd number is false and 2 is even number is true. Now if one statement is true and second statement is false, at that time new statement which you are getting by connecting them by or is what? 2 is either even or odd. Just I am using what? Or. 2 is either even or odd. 2 is either even or odd. 2 या तो इवन हो सकता है या तो ऑड हो सकता है, दोनों में से एक कोई तो भी है. सो यस 2 is what? Even. So means if at least one statement is true, so result will be what? True. Hope you are getting it. If I am saying that Taj Mahal is in Agra or in Delhi, ताजमहल या तो आगरा में या तो दिल्ली में है, दोनों में से कहीं तो भी एक जगह पे है. तो हाँ एक जगह पे है, आगरा में है. सो isn't it at that time statement one part is true, one is false, but if you are connecting them by or, at that time it will become what? True. Is it clear? So in simply you have to remember that at least one part, at least one statement is true, result in case of disjunction will be what? True. Means if at least one statement is true, at that time result will be what? True. Here single statement is not true, that's why result will be what? False. So remember the ideas to remember the truth table. In case of negation, what we have seen, negation of true is false and negation of false is true. In case of and, how to remember the truth table? If at least one statement is false, truth value of and will be false. In case of or, at least one statement is true, truth value of or will be true. एक भी ट्रू आ गया और में तो रिजल्ट क्या आएगा? ट्रू ही आएगा. सो इन दिस वे इजीली वी आर एबल टू रिमेंबर द ट्रूथ टेबल ऑफ दिस लॉजिकल कनेक्टिव. Now let us discuss about symbolical representation and truth table of our fourth logical connective, that is if then. The alternate word for if then is what? Conditional. Means if then, if two statements are connected by which logical connective? If then, at that time that statement is called as conditional statement or it is called as implication. So if P and Q, now first let us try to understand the symbolical representation. If P and Q are two statements, then they are conditional. Conditional statement. Conditional statement means what? Two part. P and Q are connected by which logical connective? If then. At that time we can say that it is conditional statement. If P and Q are two statements and if we are connecting these two statements by if then, at that time it is called as conditional statement, and this conditional statement symbolically denoted by this symbol P implies Q. That's why since we are using implication here, that's why if then is also called as what? Implication. So either denoted by this notation or this implication can also be denoted by this notation, but priority is given to this notation. Okay, P implies Q. Now hope the idea about symbolical representation of fourth logical connective is clear to you, that implication is used for what? If then. Okay, now let us discuss about its truth table. Just we have seen the truth table of three logical connective, nor, or, and. Now we are discussing the symbolic, now we are discussing the truth table of fourth logical connective if then. P and Q are two statements. At that time, if two statements are connected by if then this it will be denoted by this notation P implies Q. So to discuss the truth value which you are getting of this P implies Q, we are not considering the example. Just I am telling some techniques to remember this table, because example may makes confusion in the mind. Okay, so you have to remember that if T of appears, means if first part is true and second part is false, at that time only implication is false, otherwise implication is true. So you have to remember this much condition. In case of implication, if P means first part is true and the second part is false, at that time only implication is false, otherwise implication is what? True. That's why I am not considering here any example to clear the ideas about truth table. Simply remember that if T of appears in the implication, at that time only implication is false, otherwise it is true. Means if both are true, implication is true. If both are false, at that time implication is true. If first is false and second is true, at that time also implication is true. It is false only if first statement is true true and second statement is false. Means if TF appears, at that time only implication is what? False. Now if P implies Q is the conditional statement. Conditional statement means in this case these two statements P and Q are connected by which logical connective? If then. At that time the first part P is called as what? Hypothesis or antecedent. This P means first part of the statement is called as what? Hypothesis or it is called as antecedent, and second part Q is called as conclusion or consequent. Remember that if two statements are connected by if then, at that time that statement is called as conditional statement. If one conditional statement is given to us, at that time first part of the statement is called as hypothesis or it is called as antecedent, and second part means which we have denoted here by Q, it's called as conclusion or it is called as consequent. Now let us discuss about equivalent forms. Equivalent forms of which logical connective? P implies Q means conditional statement. Means this conditional statement can be written in these different forms. At that time its meaning does not changes. Is it clear? So P implies Q can be written as P is sufficient for Q, or it can also be written as Q is necessary for P, or it can be written as P implies Q, or it can be written as Q follows from P, or it can be written as what? P only if Q. If we are writing the conditional statement in this different form, the meaning of the statement does not changes. That's why it is called as equivalent forms of P implies Q. Just consider one example. If a triangle is equilateral, here the part after if, let us consider it as P, and the part after then let us consider it as what? Q, or denoted by Q. So here if then means which logical connective appears? If then. At that time this statement is called as what? Conditional statement. If one conditional statement is given to us, at that time this first part means which you are denoted by P, it's called as what? Hypothesis or antecedent. Here hypothesis or antecedent means what? Triangle is equilateral, and Q means second part. It is used for what? Triangle means triangle is equiangular. Triangle is equiangular is Q part, and this second part is called as what? Conclusion or consequent. The part after if, let us denote it by P, and after then denoted by what? Q. If P then Q means part after if it's P and part after then will be Q. So P and Q are known to us. Then this statement can be written in these different forms, and these different forms are called as what? Equivalent forms of which conditional statement? P implies Q. So this statement can also be written as P is sufficient for Q, means triangle is equilateral is sufficient for triangle is equiangular. Meaning does not changes. That's why these are called as equivalent form of this conditional statement. Again this statement can be written as what? Q. Q means what? Triangle is equiangular is necessary for triangle is equilateral. So P implies Q means triangle is equilateral implies that it is equiangular. Again Q follows from P. Q means what? Triangle is equiangular follows from it is equilateral. Again P only if Q means triangle is equilateral only if it is equiangular. In this way this statement can be written in these different forms. At that time meaning does not changes. That's why we are saying that these are the equivalent forms of which logical connective? If then. So in this way we have discussed about four logical connective. Not it's called as negation, or it's called as disjunction, and it's called as conjunction, and if then it's called as conditional statement, or it is called as implication. Now let us discuss about the last means fifth logical connective. So our last logical connective is what? If and only if. If and only if in short can be denoted by IFF. IFF is the alternate notation for if and only if. And if two statements are connected by if and only if, at that time the statement which you are getting is called as biconditional statement, or it is called as double implication. It is called as double implication because symbolical representation of biconditional statement is double implication. Means in this case P also implies to Q and Q also implies to P. So hope the alternate word for if then is very clear, if and only if is very clear to you. If two statements are connected by if and only if, then that statement is called as biconditional statement, and its symbolical representation is double implication, so it is also called as what? Double implication. So these are some ideas about symbolical representation of our fifth logical connective. Now let us discuss about its truth value. If two statements are under consideration, at that time we have seen that four possibilities of truth values are there, and these possibilities can be written as what? True true, true false, false true, false false. This is the standard method to represent the truth value. So now if we are connecting these two statements by double implication, at that time see what result we are getting here. So if both the I am just telling you the technique to remember this truth table. If truth values are identical, means exactly same, at that time remember that the truth value of double implication will be true. Otherwise false, means if truth values varies, means if one is true, another is false, at that time false. If first is false, second is true, at that time also false. When the truth values are true, if truth value of both the statement are identical, means same, either both are true or both are false, at that time truth value of double implication, means if and only if, will be true. In this way you are able to remember the truth table of our fifth logical connective. Now let us discuss about equivalent forms of this biconditional statement. Equivalent forms of biconditional statement P if and only if Q, means the given statement P if and only if Q can also be written as P is necessary and sufficient condition for Q, or it is written as P implies and implied by Q. So all these are nothing but ideas about symbolical representation and truth table of our 5 logical connectives. Using this result we have to solve the remaining example from exercise 1.1. So this example we will solve in the next video.